Okay, so our second video here is providing our steps in order to solve any linear equation I want to find. So if I want to solve a linear equation, our ultimate goal is to solve for x. That's what we're going to do. So you have to isolate x and get x on its own. So all our final answers, no matter what we look for, should be something like x is equal to our final answer. So that's our goal now, all right? And some of the equations are quite easy to do where you don't require many steps, but as we get further and further into more complicated equations, then I would like to use these three rules that I've created and these two little sub rules that we use attached to these main rules here, all right? So if you are completely lost on linear equations, or if you're doing advanced linear equations, I would suggest you use these three rules to go about and solve any linear equation you want. For example, in this simple linear equation, what plus 7 is equal to 3? Well, this isn't too hard. Most of you would say, well, it's quite easy if I say x is equal to negative 4. Negative 4 plus 7 is equal to 3, which is correct. But we want to start using rules so that when we get more difficult linear equations, it becomes easier and easier to do. So let's take a look at our rules. First of all, number one, whenever I get a linear equation, I eliminate all fraction parts of the equation. Okay, meaning we want to get rid of anything where there's something out in the denominator. We want to cancel out anything in the denominator. So if you look at this example here, we don't use rule 1 because look, there's nothing in the denominator here underneath this one or underneath this one here. So sometimes you won't use these rules, okay? So rule number 1 for this simple equation we don't use. Rule number 2, put all x terms on one side of the equation and all constant terms on the other side of the equation. So we do use rule number 2 here. So I'll put a number 2, meaning we use rule number 2. So in order to do this, we need to maintain balance. So I would like all x's on one side of the equation and numbers on the other. So I want this 7 onto this side with his other constant term. So that's what we call the constant term, remember? So in order to do that, to maintain balance, if I put negative 7 on this side, I get 0. But I would have to put negative 7 on this side as well, won't I? So these two cancel out. And I have 3 minus 7, which is negative 4, exactly what we thought it was in the first place. So not too difficult. But we're going to continue using these rules as well. So in this case, we used rule number 2. And the last bit says divide out any coefficient in front of x. So a coefficient in front of x, in this example, 4 is the coefficient in front of x. But the only one we have here is the hidden 1. And that is perfectly acceptable. We want that hidden 1 in order to solve this, okay? So if we look at these sub rules, it says expand when possible. Well, I didn't have to expand, and add like terms when possible. Well, the only thing I had to add was the 3 and the negative 7. So technically these are like constant terms. So these two rules, we want to continually adjust and look and see if we can use them while using these three rules. And we'll use an example later on and check how to do this. So let's look at question 2. X over 5 is equal to 20. Once again, you could probably figure this out without any of the rules, but let's apply the rules just so we have them. So this was rule number 2 there. So first one, eliminate all fraction parts of the equation, meaning cancel out the denominator. So in this case, there actually is a denominator. So to cancel out this denominator, if I put a 5 up here, over top near the x, they cancel this out. 5 divided by 5 is 1. But whatever I do to one side, I have to do the other side. So I have to times this side by 5 as well. And if that's the case, we get x is equal to 100. And if you look here, now we've solved for x. We don't even have to look at any of our other rules. So in this example here, we use rule number 1 only. Okay? Let's look at this example here. So, rule number 1, Eliminate all fraction parts of the equation. Okay, and there's no fraction parts here, nothing in the denominator. But if you look here, we look at our expand when possible. So I look on this outside and I ask myself, can I do these two rules at any point before continuing on with this 1, 2, or 3? And I can. So I need to expand here to continue on with any of these rules. So the first thing you should do is ask yourself, is there anything you can expand right away? So if you do that, you have negative 15x, negative 5 times 1 is negative 5, is equal to 35. Okay. Now, next piece is, well, we already know we don't have any fractional bits. We don't have any fractional parts in our equation. So part 2 is put all x terms on one side of the equation and all constant terms on the other side of the equation. So how about we take this negative 5 and put it onto this side here? So in order to do that, if we add a positive 5 on this side, they cancel out. But I have to add a positive 5 on this side here. So when I do that, I have negative 15x is equal to 40. And then now look at this step 3. So far we've used substep I. So I'll put that here circled. Eliminate all fraction, we didn't have to do that. Put all x terms on one side of the equation and all constant terms, we use step 2. And finally, step 3 is divide out any coefficient in front of x. So if I divide this by negative 15, they cancel, and I would divide this by negative 15. So I used step 3 in this as well. So like I said, look, I only use step 1 or step 2 in this one, step 1 in here, and step 2 and 3. So the main thing is looking at these and following these steps. If we reduce this, we get 8 over 3 negative, because they're both divided by 5. All right. So let's look at this one here. 6x is equal to 42. Eliminate all fractions, meaning get rid of any denominators. There's no denominators, so we can go on to step 2. Put all x terms on one side and constant terms on the other. Well, it already has occurred because we have our x term on this side, our constant term on this side. If we look at these rules, if I were to look at them from the very beginning, there's nothing to expand and there's no adding like terms. So finally we get to rule 3, divide out any coefficient in front of the x. So I divide this by 6, divide this by 6, and we end up getting x is equal to 7. All right. Let's go to the next one. Here, can I expand or add like terms? Nope, so I don't use rule I or II. Can I eliminate any denominators? No, I don't use rule number 1. Rule number 2, put all x's on one side and constant term on the other. I can do that if I go minus 3. This eliminates my 3, and I end up getting negative 5x. What's 18 minus 3? I'll put it down here so it's a little bit easier to understand. 18 minus 3, well, that's 15. So that's rule number 2 we used. And then rule number 3, divide out the coefficient in front of x. Divide out by negative 5. Divide out by negative 5. X is equal to negative 3. So there we go. So we used rule 2 and rule 3 in this example. Okay. How about this one? This one's a little bit more tricky. Okay. So it says expand when possible, no expansion, add like terms. Well, we don't have any add like terms here. But if we look at the next rule number 1, it says eliminate all fraction parts of the equation. So we could eliminate this 2 here immediately, but this is an exception where if I put all x terms on one side and coefficients or constant terms on the other, so if I take this 7 and I throw it over here, it might be a little bit easier. So to do that, I put negative 7 here, and I have x over 2 is equal to minus 3 minus 7 is minus 10. So here's an exception where I decided to use rule 2 before rule 1. And the reason why I did that is because now, if I want to get rid of the fractional bit here, I can times by 2 up there, and times this also by 2. And now I have my x is equal to negative 20, okay? It's possible, if you want to see what would happen using rule 1 first, if I did this, okay, if I were to use rule 1 first, what I would have to do is multiply this term here, I would have to multiply this term here, and multiply this term here. This would get rid of my fraction bit, but I would add this bit here, plus 14 is equal to negative 6. Now if I take this here and I put the negative 14, I want to put all my x terms on one side and my constant terms on the other. I could put minus 14. This goes away and we end up getting x is equal to, well, negative 6 minus 14 is negative 20, and we get the same answer. So you have two different ways that you can do this here, if you like.